In this video I'm going to return to the subject of improving the quality of a depth profile calculated from XPS spectra. In this case I would like to look at a spectrum measured that is nominally the vanadium 2p, but the interval includes oxygen 1s also. And this has consequences when we want to do noise reduction, because if we perform principal component analysis we end up with a significantly higher number of abstract factors, 6 at least, because of combining the oxygen with the vanadium. So to allow us to focus on just the vanadium and calculate the signal for these relatively noisy vanadium peaks, what I'm going to use is this toolbar button that creates spectra from regions. And what this means is that I will be able to define a region for the vanadium 2p, and I can also define a region for the oxygen 1s, and then I can use this button to create a new VAMAS file that contains 2 VAMAS blocks where there was previously 1. So we need to create 2 regions on these data, one representing the vanadium 2p and one representing the oxygen 1s. So to indicate the region I'm interested in, I'm zooming into the data, press the create button and then make an adjustment to the limits of this region, and this is vanadium 2p. I would like to do the same for the oxygen 1s signal, so zooming in to an energy interval that represents the oxygen 1s, making minor adjustments to these limits, and now I have a region that also represents oxygen 1s, and these names are important because these will be the names that will be assigned to the VAMAS blocks that are created in the new file. So naming the regions correctly is something that we should do before using this button that will create spectra from regions. Now as it stands, I've got a region defined for the oxygen and one for the vanadium 2p on one of these VAMAS blocks. So since they are now selected, I can propagate these regions so that the entire set of vanadium 2p spectra now have these same 2 regions defined, and then pressing the toolbar button I can create a VAMAS file that now contains the vanadium 2p on its own. And the advantage of this can be seen if we perform PCA on these data and then look at the number of abstract factors, and it's about 3 that would represent signal. So this means I can perform PCA on the vanadium alone and not have to include the variation that would be associated with the oxygen. So PCA applied to the oxygen, how many do we have in this case? 1, 2, 3, 4, 5, 6, 7, 6. So we've split the variation between the oxygen and the vanadium, and therefore the PCA can apply the decomposition to just vanadium or just oxygen, and therefore we don't get so many abstract factors that are significant for the data that is actually noisy. So let's reconstruct these vanadium with 3 abstract factors. We can see the enhancement has occurred, and then if I copy back to the original file using the toolbar button that is designed to produce a copy of the data that is the process data, not the original data. So this will take through the abstract factors enhanced data, and it will also add a number to the element transition fields which appear here, and therefore the new data will then appear as a new column in the original file. So now I have a column that represents the signal enhanced vanadium 2p, and this now can be included in the calculation of the depth profile and should produce a smoother trace in the profile as a result.